What's up, logic fans? Welcome back to another video. Today we do section 6.11 of the text, our 11th section on quantificational syntax, and here we begin looking at quantificational statements that involve identity and how to handle such statements with respect to all of our new rules, UI, UG, conditional proof, indirect proof, quantifier negation. And in the following section, after we've introduced a whole new rule just to handle identity statements in the present section. We're going to call it identity substitution. We'll cover that here. In the following section, we look at how you can prove some very interesting and fun results, prove some theorems concerning identity in section 6.12. All right, let's rock. All right, so I want to open talking about just a sort of warning to the student. So identity is an active area of research in logic and philosophy. So we're going to do some things here, and there are some known paradoxes and problems associated with identity. So, you should take everything here with a grain of salt and pay very close attention to what your professor has to say about these things. So if you're using, a different textbook, or if you're using this textbook and your professor's telling you some things about identity, just sort of note those and keep those in your back pocket, because they're very, very important for you to know about. And the fact of the matter is, we just haven't completely ironed this out exactly as we want it to be yet. But we can do a lot of things, and so let's explore some of that and get you started with it now. Okay, so let's start with an important skill, which is how to use quantifier negation in accordance with quantifier negation and double negation in accordance with quantificational sentences involving the identity symbol. So let's go ahead and try this now. Focus on just sentence A here. A is identical with B. And go ahead and apply double negation to it. And what would the result of applying double negation to sentence A be? Pause now. All right, hopefully you're able to get it. And we would accept two different sort of notations here. But the idea is you just take this whole thing in parentheses and you apply the double negation to it right there, and it would yield this. Alternatively, you could have written the same thing this way, where you just apply the negation through here and then the additional one out here. So these will be regarded as logically equivalent statements for us, okay? All right, let's go ahead and apply the double negation to sentence B here. What would you get for that? Pause. Okay, and so we would accept two different sort of solutions here that we will regard as equivalent. But yeah, so you could just surround this whole thing in parentheses as we've done here, and then apply the two negations to the outside. Alternatively, you could just take one of these out and write it's not the case that A is identical with B. And we will sort of, as a conventional notation, sort of allow either of these ways of doing it. Okay, let's try something a little bit different here. Here we have in C an identity statement with an existential quantifier attached to it. And what we want to do is switch quantifiers. So we want to switch from the existential quantifier to the universal quantifier. Let's see if you can't figure out how to do that. Pause now. Alright, so in this case we start with an existential quantifier. There's at least one thing that is identical with itself, and in order to apply quantifier negation, which is what we need to do to switch the quantifiers, we have to have a negation to work with. So you could have applied it either in here or out here. In this case, I chose to apply it out here, and then you just apply the quantifier negation, right? Taking this one and moving it to the inside and switching the quantifier and preserving all else, and you're left with this expression, and that would be the correct way to switch quantifiers using QN with an identity statement. All right, let's keep trying some others. How about D? Go ahead and switch quantifiers from the existential to the universal with sentence D. Pause now. Okay, hopefully you got it. This case was easier because you actually had a negation to work with from the given, and so all we're going to do is apply quantifier negation, take it in, and you're left with this expression. Interestingly enough, if you recall, a sentence like this, it's not the case that there exists at least one thing that's identical with itself, would be a sort of symbolic way of expressing the idea that nothing exists, that it's not the case that there exists at least one thing, right? Because everything is identical with itself, a principle that we'll be going over shortly. But yeah, this is how quantifier negation would be applied. Okay, what about sentence E? Let's go ahead and switch quantifiers on this one. And what I mean by that is you only have to switch this quantifier from the existential to the universal. You can leave this one if you like, okay? So pause now and try that. Okay, and so the point here is that we handle this the same way we would if this was just like a relational expression like rxy or something in here. We take this, we move it inside, right? And we switch the quantifier and we preserve it in terms of y. And so this is how Qn works with identity statements. All right, let's keep rolling. Try f now. And for f, once again, all you have to do is switch this quantifier, this one only, from the existential to the universal. Pause now and try that. Right, so in this case you actually have the negation here, and we pull it out here and switch the quantifier, and that's the correct application of Qn with the identity statement in this case. So hopefully you're really getting a feel and comfortable that you can just sort of apply Qn in the intuitive way for identity statements. All right. Let's try a bit tougher of a problem, and in this case what I want you to do is I want you to take this leading negation and I want you to push it all the way to the far right. I want you to push it all the way over here as far as it can go to the right using Qn. So pause now and see if you can do that, and what would the resulting expression look like pushing this negation all the way over to the right as far as it can. Pause now. Okay, so for this case, what you're going to do is you're going to apply Qn twice. So first you're going to take this one and move it over here and switch it to x, right? And that's going to leave you with this expression. Then you're going to take this one, right, and you're going to use Qn on this expression, and you're going to take this one and move it all the way over here, and you're going to end up with there exists an x, there exists a y, such that x is not identical with y. In other words, there exists at least two things, okay? And this is an important skill, being able to push using Qn, the negation all the way to the right or all the way to the left of an expression, and this does come in handy when identity is involved. So let's go ahead and try this once again, this time with sentence H. Push this leading negation here all the way to the far right and see what you end up with. Pause now. Okay, and again, all you're doing is you're doing it step by step. You take this one, you move it over, you switch the quantifier. You take this one, you move it over, you switch the quantifier. And then, of course, we can just use double negation. That was the point of these exercises back here with A and B, to rewrite this expression this way. And so you end up with this really nice clean thing. There's at least one thing x, there's at least one thing y, such that x is identical with y. Okay, great. Let's go ahead and try I. And all I want you to do for I is take this one and move it over to the far right. Pause now. Alright, and by now this one should be really easy, right? You just move it, you switch the quantifier, and you're left with this expression. But what happens when you do the same thing in J, but you've got this non-identity symbol in here? So take this one, move it to the far right, and what are you left with? Pause now. Alright, so in this case, you take this one and you move it over and you get the not, right, like this. And so after you double negate and clean that up, you end up with this expression. So that's how Qn works with identity statements, and these are important skills, okay? So keep those in mind, and let's press on to the next topic. Okay, so in order to prove that certain arguments are valid, arguments that intuitively appear to be valid are in fact valid. In order to have proper syntax of identity for proving the validity of arguments that involve identity, we're going to need to introduce a new rule. In fact, we're going to have to introduce two new things. We're going to have to introduce a new rule, which we're going to do now. That new rule is going to be called identity substitution. We're also going to have to introduce an axiom, which we do in 6.12. But for now, let's just focus on identity substitution. And by way of informally motivating this new rule, I want you to see if you can't solve this very simple syllogism, right? So we're intuitively motivating the notion of identity substitution. So here you've got two premises. The first one, Superman can fly. Second premise, Superman is, and maybe even more directly, is identical with Clark Kent. Okay, so identity equals Clark Kent. Okay, Superman can fly. Superman is identical with Clark Kent. Now, something follows from these two premises. Pause now, take a second, and see if you can't figure out intuitively what follows from these. Okay, hopefully you got it, right? And the idea is pretty straightforward, and that's what it's supposed to be, right? If this thing has a certain property, or if this thing is a certain way, and that very thing is identical with this thing, then this thing is going to have that same property, right? So it's kind of interesting, but let's see here. Symbolically, we might sort of represent this argument this way, right? If we really had to, we might say, you know, Superman can fly, represented that way, and we might write Superman is identical with Clark Kent this way, and then we would conclude, right? Pause now, actually, and see if you can't figure out symbolically how we would write the conclusion given this symbolic apparatus so far. All right, very good. So it would be like this, you know, FC. And so what we need is basically a rule that allows us and licenses us to make such an inference. So that's exactly what identity substitution is. So it's going to be a new rule, a rule that we're going to make extensive use of in this section and the next. So let's go ahead now and formally state the rule, and then we'll do lots of examples to make sure you're clear on the nuances of the rule itself, okay? Okay, so allow me to formally state the new rule, identity substitution, and we'll get into some examples of how it works thereafter, but let's just get the formal rule on the board. So let alpha and gamma be any individual constants or pseudonames, so they can be little a, little b, little c, or they can be u, or they can be v, all right? Given any two sentences, like so the first of which involves a alpha, let's suppose it's S, like here, and then if you have that thing S is identical with something else as you do here, like C, then you can infer this sentence replacing this with the C, right? Replacing the alpha with the gamma, provided gamma replaces at least one token of alpha. So here there only was one token, but if there were two, you would have to replace at least one of them, not necessarily both, and you can't make any other changes. Okay, so that's as we've done here, and that's the intuitive motivation for the rule. So since we're running out of time, what I'm going to do is I'm going to spill this over into the next video, and we'll do a few exercises to make sure you really understand the rule identity substitution. Look for the second video on 6.11.